Hi, everyone. We're going to go over lipogenesis or making lipids. A couple things to note about fatty acid biosynthesis is the first fatty acid that is going to be made is actually saturated fat, which is synthesized in the cytoplasm of the cell, and it is palmitic acid. And then through the process of desaturases and elongation, we can increase the chain length because if you recall, palmitic acid is a 16 carbon fatty acid, and elongase can continue to add on acetyl-CoA to increase the length of that fatty acid chain. And then in addition, we would have desaturase, which is going to add in double bonds. And with this process, there are the two essential fatty acids that our body physically cannot make because we don't have that enzyme ability. One of the things to note is that acetyl-CoA is the building block. And so we'll talk about how do we actually access acetyl-CoA since it's trapped in the matrix of the mitochondria, and we need to get it out into the cytoplasm. This step is regulated by acetyl-CoA carboxylase, which is again the enzyme. This enzyme gets turned on or basically stimulated during a fat-free diet or a very high carbohydrate diet, right? So our body does need fatty acids to be able to have various items such as triglycerides, lipoproteins, cholesterol, and so forth. So here, that's what we're going to be looking at of how we actually start making fatty acids. In another video, we'll look at the ketone production. So when we first look at lipogenesis or creating these fatty acids, it's important to note that the location is inside the cytosol. So if this is our cell here, and then the blue triangle is our mitochondria, specifically the matrix, we need to get the acetyl-CoA outside into the cytoplasm. So in order to do that, OAA is going to combine with acetyl-CoA, such as those first steps of the Krebs cycle, to then become citrate. At that point, citrate can actually escape the matrix and come into the cytosol. From there, citrate is going to get broken down into the two individual OAA, so oxaloacetate, and then A-CoA, acetyl-CoA. Right? So this acetyl-CoA, we already talked about how that is the building block of fatty acids. Now, this step does require ATP, so we're going to have to put in energy in order to get citrate to break into OAA and acetyl-CoA. And then we continue to add on these acetyl-CoAs. It goes to malonyl-CoA and then so on to make palmitic acid using the fatty acid synthase complex. Now, when we look at how we take acetyl-CoA to then make a triglyceride, which is how we store fat in the body, so maybe we're making fat because we have too much glucose in our body from that high carbohydrate diet. We don't need the ATP from glycolysis, so our bodies are going to start making fat. We can also make fat from eating too much protein, which we'll cover in the protein section. So acetyl-CoA becomes that palmitic acid, and then we use elongation to add acetyl-CoA to make fatty acids longer than those 16 carbon chains. And then we're going to be using desaturase to add double bonds into those fatty acids as needed. So when we look at desaturase, a few things to make a note of is that a high amount of dietary saturated fat and trans fat actually impairs the ability for us to metabolize those essential fatty acids. So if you recall, the essential fatty acids are your alpha-linolenic and your linolenic acid, so the omega-6 and omega-3. And that is because as we are trying to process these fatty acids, there's competition to use this enzyme. And so if our diets are overwhelmed by our dietary saturated fat and trans fat intake, we're not able to produce other essential fatty acids. Now, basically the 5-carbon and 6-carbon desaturase, this is a critical role for us to metabolize those essential fatty acids. And this is going to increase in a fat-free diet because our body is trying to make the other fatty acids that are important for our body's function. We also see an increase in these enzymes when we have insulin present. Again, the higher insulin comes with a higher carbohydrate load, meaning that someone's typically eating too many like sugary foods to then make more fat in the body. These desaturases get decreased with high alcohol consumption, low protein diets, and then as well as somebody who has diabetes. So this is, again, something that we'll talk about when we get into the lipids and disease section. One other note is that an excessive amount of omega-6 fatty acid intake is actually going to reduce our ability to metabolize omega-3 fatty acids. And our traditional American food diets are very high in omega-6 fatty acids and relatively low in omega-3 fatty acids. So omega-3 fatty acids are your ALA, EPA, and DHA. So we certainly need to be consuming more of those foods that are rich in omega-3s and reduce the amount of omega-6, like your vegetable oils. And that's all.